Good morning, this is your Stat Sensei, Mr. Spensei, and we're working on the chi-square test review. And this will be a goodness of fit. Where's your crib? The study was conducted to determine where moose are found in a region containing in a large burned area. So they want to know where the moose are. A map of the study area was partitioned in the following 4 habitat types. It's believed that more than 4,500 moose make this area their home. All right, so it looks like we have a population size of 4,500. Our habitat areas are the first one, inside the burned area. That's right here. The next one is in the burned area near the edge, outside the burned area, and then outside the burned area, not near the edge. All right, so there's the drawing of it. The proportion of total acreage in each of the habitat types was determined for the study area. That's another way of saying frequency or percentage. Using an aerial survey, moose locations were observed and classified into one of 4 habitat types. The result area given in the table below. So we had these proportions. So as the percentages, and they have to sum up to 1. And this was the number of moose observed. So they found 117 while they were flying. The researchers who were conducting the study expect the number of moose observed in a habitat type to be proportional to the amount of acreage of that type of habitat. So in other words, they're saying, hey, if this is 34% of the acreage, then 34% of the moose, 10% of the acreage, 10% of the moose. It says, are the data consistent with this expectation? In other words, do they follow these percentages? As soon as they indicate that we're following these percentages, we're looking at a chi-squared goodness of fit. And they want us to test this at an alpha level of 1%. All right. All right. One thing it does not say is it does not say random sample. We're going to need to fix that. So we're going to, for here, say that it has it, but then I need to fix that for what you all see. So it doesn't have it here, but it will when you see it. All right. So first thing, our null hypothesis. Remember, your null or your ho has to always be positive. So the population distribution of moose is proportional to the habitat acreages. All right. The ha is a negative statement. So if this is proportional, this is going to be is not. So the population distribution of moose is not proportional to the habitat acreages. Next thing was we need to get the expected values. To do this is different than the chi-squared test of independence. Test of independence, we need a matrix. Here we have to go to stat edit. So in stat edit, I put the observed values, always put the observed in L1. So these go into L1. And then I put the percentages into L2. So that's what I have in there, but we're not wanting percentages, we want expected values. So to get that, I go all the way up to the top of L2, second 2, and I multiply by the sample size. Well, the sample size is 117. And so now I have 39.78, 11.81. These are my expected values. So the expected values for this one was 39.78. The expected value for here was 11.817. Here was 12.168. And right here we have 53.235. So we then went on and went ahead and did the conditions. Random sample of 117 given. Actually, it wasn't, but we're going to fix that for when you see it. N is 117. 117 times 10 is 1,170. That's less than the 4,500. Remember, that's the population. They indicated that there was about 4,500 moose. All expected values are greater than 5. Our smallest is 11. Remember, as long as it's greater than 5, we don't care how close to it. The formula is observed minus expected over expected. Remember, it's categories minus 1. In this case, we have 1, 2, 3, 4. So 4 minus 1 is 3. So our degrees of freedom here is 3. All right. Remember, when we set up our plugs, when we plug in, we concern ourselves with the first one and the last one. So 25 minus 39.78 over 39.78. 40 minus 53.235 over 53.23. Now I cut these down to 2 decimals so that they would fit. Let's see what happens when we run the test. So stat, test. This time it's a chi-square goodness of fit because we want to know if it fits the distribution. Does it fit the proportion? L1 and L2 is where our observed and expected are, and our degrees of freedom are 4 minus 1. And we end up getting a very large chi-squared and a very, very small p-value. Now remember, that looks like that's a 1, but you can never have a probability greater than 1. This has 8 zeros in front. So our probability of getting a chi-squared equal or greater than 43.689 is equal to approximately 0, which is definitely less than alpha of 0.01. That's what they gave us, which means we're going to reject the null. So with that in mind, the p-value is approximately 0. We reject the null. There is plenty. We have lots of it. We have sufficient evidence at alpha equal 0.01 to suggest that the population distribution of moose is not proportional to the habitat acreages. Where did that come from? That came from where it always does. It's a restatement of the alternative. The population distribution is not proportional to the habitat acreages. Remember, in our conclusion, we're always restating our alternative hypothesis. All right, I hope this helps, and I sure hope to see you on the next one. Thank you.